Greetings, my able technicians. I hope we are all learning and we are all growing day by day. Okay, today I'm presenting this circuit for us to study, and it has to do with network section. Okay, so we understand that there are different faults that may arise if a network section is faulty. Okay, there are times that you will see no network in your mobile phone, you will see emergency call, you will see no service, a lot of things, and you will also see no SIM detected or SIM card not detected. Okay, these are the various faults that we will come across when our network section is faulty or our network circuit is faulty. So today I'm going to pick a certain issue that do occurs when our network section is faulty. SIM card not detected. Okay, this fault is different from no service. Okay, it's also different from emergency call. So when you have faults like this, you have to know the circuit to work on. So in this type of circuit, I will explain the fault that shows SIM card not detected or SIM card not inserted. So this is the circuit, and I promise you, if you learn and understand and study how this circuit works, you will be able to solve that issue. Okay, I want to explain something for us to understand. This is 5G circuit. 5G circuit. This circuit is slightly different from how 4G circuit works. Okay, very, it is slightly different. Okay, so we are going to study our 5G circuit. This is our 5G phone. Let's call it Samsung because most of the Samsungs comes with 5G. So this is our 5G circuit. Now I want to explain something. This is our power IC. This is our NFC IC. In 4G, you won't see this NFC IC. Most of the 4G, you won't see this NFC IC. So this is our CPU, and then this box is our SIM tray. This is our SIM tray box. This is where you insert your SIM tray. So this is the circuit that we are about to study. Now, I want to explain something for us to understand. We have different generations of phones, mobile phones. So in our keypad, how this section works is different from the way Android section works, 4G, and then 5G is also different from the way 4G section works. So I'm explaining this 5G section. So now, when your phone does not show SIM card detected, like when your phone shows SIM card detected, the first thing that have to come into your mind is that you have to change the SIM. Okay, there's sometimes that you might put a faulty SIM, or the SIM is not good, then it will not detect. Your CPU will not detect. So you have to test another SIM. After testing another SIM and you see that it still does not display SIM card, the next thing you have to do is to open the phone and examine this SIM tray port. This is our SIM tray port, also you can call it SIM jack. So this SIM tray port, it normally have 6 pins: clock, reset, vSIM or VIO, then data, NC, and ground. This NC stands for not connected. So in this pin, you won't get any readings because it's not connected. So now, after examining this SIM port, you have to take diode readings on these 6 pins. The first pin, which is our clock, will give you readings because it's connected to our CPU direct. Then our second pin is our reset pin, so it will give you readings. So it's going to give you, let's say, 250 to 600 or 800 diode readings, depends on the meter that you are using. So now our vSIM, this pin stands for this is our voltage pin. This is our pin that receives voltage. You can some circuit you will see VIO. So this will give you reading because it's connected to our NF-CIC. And then this pin is our ground. It's going to give you a beeping sound. Now this one will give you no readings, OL, because it's NC. Then this our data. This our data pin is going to give you reading because it's connected to our CPU. And it's also connected to our power IC. Okay, so after taking the readings, if you discover that this one or this one or this one or this one is having a short, it's giving you a beeping sound, you have to work on that particular pin, because there are capacitors connected in each of the pin. Each of this pin, the lines that is connected from this pin to our CPU, there are capacitors. The same thing applicable to this clock and then this VSIM, voltage for SIM. So it like this one, I put capacitor here. So any of this pin can have short circuit. So if you discover that, or you realize that any of this pin is shorting, you have to trace this pin, the line that is connected with this pin. When you trace it, you have to test the components, and then you know how to apply your inject voltage on this particular line. But before injecting voltage, know the amount of voltage that passes through this line before you inject. Don't inject excessive voltage into this line, so that it will not damage this line. So another thing that can happen is that any of this line might be open. The ground might be open. If this ground is open, it will not detect your SIM. So you have to connect this ground, this pin, to your ground. If any of this pin is having open circuit, the line can break, maybe due to falling or anything can happen. Then any of this line can break. If any of this line breaks, it means that your phone will not indicate SIM. So you have to trace this line and then run the jumper. Ensure that you follow this line using your schematics. So it is very, very important to understand how to trace your circuit using schematics diagram. So after connecting this line, you discover that your phone will now detect SIM. But in case there is no short circuit and there is no open circuit, you have your value. Now what can be the reason why your SIM or your phone is not still detecting SIM? So now let me explain the rest of the line. Now we see here, this is our SIM detect. This particular line is connected to our power IC. It comes from our power IC. So it has 10K resistor here, and it enters this our SIM tray port and also goes to our CPU. Now this is called SIM detection line. Now in our keypad phone, you discover that if you inject, before you put your SIM card, you have to remove your battery. Okay, now when you remove your battery, that's when you will have access to the SIM tray port. Then you inject your SIM card. Then after injecting your SIM card, then you put your battery back and then try and you on it. Now at that process of removing the battery, putting your SIM card and then on the phone back, you notice that we do not have this SIM detection line. I will tell you how this SIM detection line works. Now in other Android phones, you will put the SIM card. You will not need to remove the battery, because the SIM tray port is located outside your battery. So now you don't have to remove your battery. So now you discover that when you put your SIM while your phone is on, when you put your SIM, you discover that the SIM is not detected until you restart the phone. That's when your SIM will show. It means that this line is not used in that type of Android phone. This detection line is not used. So when you put your SIM card, when your phone is on, you have to restart the phone for that SIM card to show. It means that it is only after restarting the phone that the CPU will be able to sense that SIM card. Without restarting, your CPU will not be able to know that you have inserted SIM card. Now, when we go to higher versions of Android, they bring in this line. SIM detection line. And this is how this line works. Even though when your phone is on, you insert your SIM card, your CPU will detect immediately that you have put in SIM card, and then it will indicate. It is this line that is working, this SIM detection line. There is how this line works. Immediately you insert your SIM card. Now, most of the phone, this line is always connected to ground. It's always connected to ground, this pin. So when you put your SIM card, there is a string that is connected in this line. When you put your SIM card, your SIM card tray will press that pin, and then it will separate this pin from ground. It will separate it from ground. I'm going to show you the pin. This is the pin I'm talking of. So now when you insert your SIM card tray, it's going to disconnect this pin from ground, and you will have logic high. So when you have not inserted your SIM, you are going to have logic low, because this line is grounded. And now the CPU realize that this line is ground, so it's not going to detect anything. But when you insert your SIM card tray, it will disconnect this pin from ground. Now this voltage will flow through this line. Now CPU will be able to sense that something has happened. Let me tell you how this thing works. Now 1.8 volt is coming from your power IC, and we have a 10k resistor, 10,000 ohms resistor here. Now if this resistor is damaged, your SIM card will not detect. Even when these pins are giving you values, your SIM card will not detect. So now you have to ensure that you test this resistor. It carries 10 ohms. In this 5G circuit, it carries 10 ohms. So now when you locate this resistor, test if you get voltage, this 1.8 voltage. And before you get this voltage, you have to connect it. You have to connect your SIM tray. You have to connect your SIM tray. Before you get voltage on this side, you must connect your SIM tray. But without connecting your SIM tray, you will get voltage on this side of the resistor. Now, if this resistor is giving you higher value or lesser value than this 10k, it's going to stop your SIM from detecting. So this value is very important. You must ensure that you test this resistor, and this resistor has to give you 10k. Okay. Now there are other circuits that might decide to change this resistor to maybe a different value that is not 10k. So you have to work with your schematics. So I'm explaining this other circuit that has 10k ohms. So but most of the circuit you will see will have 10k, because this is how this circuit works. So test this 10k resistor. If it's faulty, you remove this resistor and put 10k resistor. And after removing the 10k, or before removing the 10k resistor, test this line might be faulty or might be open from your power IC. So it's not going to send this 1.8. When you locate this resistor, your phone is switched on. When you switch on your phone, you locate this resistor. Test this side of the resistor that is coming from your power IC. It should give you 1.8. If it doesn't give you 1.8, you work on this line. You follow this line and trace, or you can jumper 1.8, because this line is connected to different lines and different circuits. So you can jumper, you can tap 1.8 that is still connected with this same line from another source, and then bring it to this resistor if it is open. So you can give 1.8 to this resistor. So now after testing it, if you discover that there is a voltage 1.8 volts on this side of the resistor, and you test this other side, it will not give you voltage. Why? Because you have not inserted your SIM card. It is only when you insert your SIM card that this other side of the resistor, that this voltage will pass. Let me explain how it works. This line is always connected, is having a logic low. It's always connected to ground, because this pin is connected, it's linked with ground. It can only disconnect it. You can only disconnect this pin from ground when you insert your SIM card tray. Now, since it is connected to ground, the voltage will not be able to pass, because this resistor is not fused. You cannot jumper it. It's not a fuse, so it won't allow this voltage to pass, because this side of the line is ground, so it won't allow the positive voltage to enter the ground, so the voltage will only stop at this other side. So now when this line is connected to ground, when you've not inserted your SIM card tray, the CPU will not send, because this old line is ground. From here to CPU and to this side is ground, because this pin is connected with the ground. So the CPU will not sense anything. It will only show that the SIM card is not connected or is not inserted. Now when you insert your SIM card tray, this pin will disconnect from ground. Now this line will no longer be ground. Now this 1.8 voltage will be able to pass to this CPU. Now CPU will sense that SIM card has been inserted. That's how the logic works. So if this line is open, it's also important that after removing this resistor, or on this side of the resistor, on diode readings, you have to test if you will get value. You might get value on this side, but you also have to test if you will get value, and the value will come from this CPU section. I'm giving you a deep explanation of this, how this circuit works. I want you to understand how it works. So also test, don't be in a rush, test this line. If this line give you value, that means it's not open from our power IC. You will get your 1.8. If this, test this side also. If it doesn't give you value, know that it's open from our CPU side. So you have to trace this line and locate where it's open, and then run jumper. Now that time that this other side will also be open, you see, it can also be open. So it's very, very important to test this line also. Now when you insert, how will you test this line? Without owning the phone, when you insert your SIM card tray, it's going to disconnect this line from ground while your phone is still off. Then you test this on diode readings, because you have disconnected from ground. You get the value from your CPU side. You get value. That's how to test it. You off your phone, insert your SIM card tray. Your SIM card tray, you disconnect this line from ground, then you test this side. You get value from your CPU side. But if you on the phone, the CPU will detect that SIM card is connected, because you disconnect this line. Now this is how these lines work. So this is the first, after taking your diode reading, this is the first line you have to troubleshoot. Now if you on your phone, you test, you get 1.8 volts, then you connect your SIM card tray, you discover that you get that 1.8 volts on this side of the resistor. If you get 1.8 volts on this side of the resistor, you know that this line is working very well. I hope you understand. If you don't understand, please drop your questions on the comment box. I'm going to answer it. So let's move to another line. I'm done with this line. I've shown you how this line works and the logic behind this line. Take your time and troubleshoot it very well. So now you discover this one will be connected to ground. This one is NC. Our next line, let's start from our clock line. When you get your value, you know that this line is connected. You get your diode readings on this preset. This preset is connected to our CPU. If it is open, you have to thread the line and run jumper. So now this is our VSIM. This is the line that controls our input voltage. If this voltage is not reaching this pin to connect with your SIM card, your phone will be showing SIM card detected, not detected, sorry. So now this NFC IC, you can only see this NFC IC in your 5G phones. Most of the 5G phones, you see this NFC IC, but on our normal 4G phones, they will not put this NFC IC. They will just connect it from this pin to your power IC. But in case you are working on 5G phones and you see this NFC IC, don't be panicked, okay? This is how this line works. Our power IC will give out a voltage. It can be 1.8 volts, it can be 3.0 volts, depends on the circuit or the models of the phone, the one that the company decide to use. They can use 3 volts, they can use 1.8 volts, and this line is our VREC, and we know that our VREC is our LDO line. So now our power IC will generate our LDO line and send 1.8 or 3.0 voltage to our NFC IC. Now I will show you how it works in schematics. Now how to trace it using schematics. Now when it enter this NFC IC, the output voltage will come. Now this NFC IC, this is the input voltage that powers up this NFC IC. If this NFC IC is faulty, it won't be able to generate this voltage to your SIM card tray. Okay, so now if this NFC IC is faulty, you have to either replace it or reball it and mount it. This NFC IC, we all know what it's normally used for. It's called near field communication. It's an IC that you can use to, like, you do transfer or you do transaction. It's a near field communication. It works like if you want to do transaction, you just bring your phone close to where you want to do and it will just connect. Okay, just like Bluetooth, if you just connect. So this is the work of this NFC IC. You see it in iPhones and most of the Samsung. So that this NFC IC, if it's faulty, it's not going to allow your SIM to be detected. So after this LDO has inputted this voltage onto our NFC IC. Now NFC IC have different lines. It plays different functions, okay, with other circuits. So this output voltage, there are other output voltages, so you have to look for this VDD NFC SIM1. Okay, we also have SIM2. Now the same, I'm explaining SIM1 circuit here. The same way the same logic applied to this same SIM1 is also the same logic applied to SIM2. So now the same way you troubleshoot this SIM1 is the same way you will troubleshoot your SIM2. So this is our input voltage for SIM1. The NFC IC will also give another input voltage for your SIM2. Okay, so this SIM1 is 1.8 voltage. So now the NFC IC inputs 1.8 voltage to this pin. You also have to test this pin if you will get this 1.8 volt. It is possible for you to get diode readings when the phone is not switched on. You get your diode readings, but after switching on the phone, you might not get this 1.8. Maybe because of the NFC, faulty NFC, or it's not generating the voltage. So it's possible. And you can only get this 1.8 volts after you have switched on your phone. And not just that, you have to connect your SIM. Remember, I wrote here after SIM inserted. So before you get these voltages, you have to insert your SIM. You insert your SIM, you on your phone. That's when you get these voltages. The only place that you will get voltage without inserting your SIM is on this side of the 10K resistor, this detection line. This side you will get your voltage, this 1.8, without inserting your SIM, but you won't get voltage on this side. Only after you insert your SIM, that's when you get voltage on this side. So all the rest of the voltages that you will require, these data voltages and this NFC voltage, you have to insert your SIM and your phone is switched on. So when you test this 1.8 volt, ensure that you get this voltage. If you don't have this voltage, you troubleshoot this line, make sure that this NFC IC, you reball it or you replace it, or you check if there's an open circuit. Ensure that this 1.8 voltage will enter this pin. Okay, after you've inserted your SIM card. So when you insert your SIM card, you won't be able to test on this pin. You'll find this capacitor and test this capacitor. Now I'm done with this pin. The next pin that we are going to work on is our data. This our data also carries 10K resistor and it has 1.8 voltage. So this voltage you can only get after you've inserted your SIM. Now it's possible for this line to be connected because when you take your diode readings, we have two IC here. So one of the IC might have open circuit. Maybe this power IC side will have open circuit. But as you are taking your diode readings, you realize that you get your diode readings. It's this CPU that's giving you that diode readings. Maybe the power IC side is open, or this 10K resistor is faulty. So when you insert your SIM, check if you get there are capacitors connected on these lines. Test if you will get your 1.8 voltage, and you also have to test this resistor if it is 10K. If the value is not giving you 10K, that means that your SIM card will not be detected. Ensure that this resistor is 10K. If it's not 10K, look for 10K resistor and replace it here. It's very, very important. This resistor plays it plays an important role on this line. So when you test this pin, insert your SIM card, you check the capacitors connected on this pin or this side of the this side of the resistor, you should get 1.8 volts. If you don't get 1.8 volts, work on this line. It's an open circuit somewhere. Channel this 1.8 volt to this side of the resistor. Now remember that you've inserted your SIM card. On this side of the resistor, the 1.8 volts should come out. When it comes out, you test it to see if you get 1.8 volts on this side of the resistor, that means that our CPU is connected. Okay, but now for you to know if this CPU is connected or not, because if this CPU side is open, you will also have value diode readings, because the diode reading is coming from this power IC. It will give you diode reading. So what you have to do is remove this resistor. After removing this resistor, test this side if you will get, or after removing this resistor, on diode readings your phone is switched off. After removing this resistor, test this pin again. If you get value, that means that this CPU is giving you the value. Now test this side of the resistor, it should also give you value, and put it back, because it's possible to get value, but this line is broken from our CPU, because this is the power IC that gives you value. So all you have to remove this resistor, test it again. When you remove this resistor, you disconnect this line, you test it again. The CPU will tell you if it is connected or not, and after that you put it back. If you get voltage, or you test this other side, if it's connected, it will give you value. When you connect it, you get your voltage. You only get your voltage after inserting your SIM card and your phone is switched on. So that is how this line works. Yes, I believe that I've explained everything that you need to know regarding this circuit. Okay, if you have any questions, you can drop on the comment section. I'm going to answer. Okay, and then please don't hesitate to like the video, share it to your loved ones, to people, to other engineers that need this knowledge also, and also comment. Okay, I'm going to show you how it works on schematics. Thank you for watching this video to the end. See you on my next video.